What do you call a factory that makes okay products? A satisfactory. Section C. This is a bit more complicated than section A and B. A and B was answer everything. Section C, you only answer 2 questions. You answer all of question 3 and all of question 4, which is all of coasts and all of rivers. I don't want to see anyone answering glaciers because quite simply I haven't taught it to you, and as a result I don't think you're going to know that much about it. So coasts we're going to start with. Make sure we answer the coasts question. So here we go again. Coasts, figure 12, a physical map of the British Isles over there. Fantastic. Match, well, I mean, you should know what that means. The following descriptions of coastal landscapes in the UK with the correct letter. So here we go then. An uneven coastline with several large islands offshore. We'll start at A and we'll just do process elimination. Have we got several large islands offshore? No. Have we got several islands offshore at B? No. Have we got several islands offshore at C? Well, actually, we've got one chunky one there, the Isle of Wight, but no. Have we got any at D? No. Well, I'll tell you what, hopefully we've got some. Oh my days, look at all these large islands off here. E is obviously the right answer there. A headland which marks the coastal limit of the South Downs. Now, unless you're in a school near the South Downs, you're probably not going to know where it is, so it's get your face into the map and find it. So look around A, can we see the South Downs? No. I can see the Crossfield, I can see Sheving, no. B, no. C, no. Oh, yeah, I can. The South Downs. It's that straightforward, people. Just use the information that's given to you. So what we got here is figure 13, an image showing a coastal realignment scheme. Once upon a time that was called Managed Retreat, but it's not a very popular name for it, so now it's coastal realignment in West Sussex. So what have we got in this image? We've got Shingle Beach, we've got an area at high tide, and we've got what looks like a lot of water in behind the Shingle Beach. Okie dokie. Using figure 13, well, okay, state, which means tell me what has happened, so something has changed, because otherwise you wouldn't use the word happened, to the area behind the Shingle Beach at high tide. So I've just highlighted there the Shingle Beach for you and the fact that it's at a high tide. So the area behind the Shingle Beach is over here. What happened to that area? It's a 1 mark question. You don't need to write reams and reams. The fact it's underwater now means it has flooded. Quite literally what has happened in this management technique is that the defences or the beach here has been literally allowed to erode and flood to allow seawater to get in behind here. That's what a coastal realignment scheme does. It quite literally allows a certain area of the coast to be eroded, or actually management itself to be eroded away, to therefore facilitate this process happening behind, which in this case is flooding. Question 3.3, another 1 marker. Suggest, which means come up with something. 1, not several. Advantage, again not plural, of the coastal management scheme shown in figure 13. Now this is a trickier question because you have to now think, well, what's the advantage of letting one area of the coastline flood? Now if anyone's got a house in there, that's not an advantage, but there must be a reason why councils often use this strategy. You could say it was cheap, but probably a better answer would be that it provides habitat. The likely reason here that this area has been allowed to flood is to provide a wetland habitat, which therefore may attract tourism to the area, which already has a shingle beach. So this is going to try and form a saltwater lagoon. That's a provision of a habitat. Some other answers is, yeah, it's cheap would work, and the concept here being that if you allow this area to flood, you don't spend any money protecting it. You can spend money on areas that might be more valuable. If you look at the image where I'm just highlighting here, it looks like towns or potentially cities there. And the idea being that you could spend more money protecting those areas rather than areas that aren't that valuable. Another little short mark question. I like this question. Use figure 14, a graph showing the rates of erosion. Yeah, okay, we've got a scatter graph there. We've got years across the x-axis. We've got rate of erosion in meters up the y-axis. Use figure 14, which means use it. What is the projected rate of erosion for 2030? And happy days, all you do on this one is you find 2030, you go up and, oh no, Oh no, the line of best fit doesn't reach 2030. What do I do? Well, what you do is called extrapolation, and you're going to take the line of best fit and extend it to the 2030 part of the graph. Quite a simple, straightforward thing to do. This is why you need a ruler in the exam. Nice straight line all the way across the end of the graph. It gives you 3.3 meters. Question 3.5 as well, we'll do that one quickly as well. 4 marker I've kept on the same page. Explain means give reasons why, it's the so what rule. Benefit, that's plural, it's trying to tell you more than one. Of hard engineering strategies. Now, hard engineering strategies work to control natural processes. The classic examples that we use are seawalls and groins and possibly rock armour as well. They are going to try and control natural processes to protect the coastline. Now this question was answered particularly well actually, considering it's quite a tricky question. It's a 4-mark question. 4 markers are written in the same way. You need 2 arguments with so what rule used after them to make your point. You don't need the use of a figure or a case study, but you absolutely can use it if you happen to know one. The example's been nice here. They've put benefits with an S to try and tell you that you need more than one. They've also told you strategies as if to tell you you need more than one strategy. So my model answer's actually been up there for a little while. We've got seawalls to begin with. Seawall is my method, and what I've done first is I've told the examiner how this strategy actually works. Seawall redirects wave energy back up to sea, reduces hydraulic action and abrasion. What I've then gone on to do is tell the examiner what the benefit of that is. The concrete structure reassures residents as it's a physical presence. My second point and so what is exactly the same. I always use groins as my hard engineering example because it's like, I think it shows off your knowledge really, that you provide a wider beach because you trap the sediment of longshore drift. It means more friction on the waves. It means waves crash on the beach and protect the cliff in behind. That's how groins work. The advantage is shown there, that the wider beach equals more tourists and more spending in the local economy. A little bit of over to you. If you wanted to write an over to you, a really good one to try and write is if you wrote the rock armour one out, I'm more than happy to mark that if you bring it down to H7 I should say. Okay, then the 6 marker on coasts. The coast section and actually the river section as well are always laid out in the same way. We'll always have 1 4 and 1 6 marker on them. Most of the time the 4 marker will be a landform and the 6 marker will be a management, or alternatively they'll switch around as they have in this case, because our 6 marker is on a formation of features. So here we go then. Figure 15 you can see there. I'll give you a second just to remind yourself of that figure a moment. Photograph of part of the Dorset coastline with some sketch maps as well. If I go back to when I was 15, 16, if only that was possible, young Mr. Toms would have looked at that image and gone, right, that's Headland Bay, and ploughed straight into answering the question over here, but that would be an error. What you want to do with figures is look at all of them, every aspect, particularly if there's a key, because it's probably going to give you quite a lot of help when you look down there as well, as you're about to see as we go through this question. So, why isn't it animating? There you go. Explain is our command word, as it almost always is on the coast questions. Explain means give reason why, the so what rule. Formation, this is a very common partial command word on both rivers and coasts. Formation means the story of, from start to finish. And then we have physical features, 2, it's a plural, of the coastline shown in figure 15. So the landforms have to be in figure 15. If you talk about, I don't know, a sand spit there for example, you ain't going to get any marks because a sand spit is not shown in its image. So here we go then, it's a 6 mark question. That would usually mean 2 arguments and PEEL to go along with it. In this case, I guess actually it technically does, you still need 2 because you need 2 features, but with a formation question you start at the beginning and end at the end of the explanation as opposed to two peels as such. You will need the use of figure, and if you can on a 6 marker, always back it up with the case study as well. So headlands and bays was the first one that you probably spotted in this question. They form when two different rock types face the sea on a discordant coastline, like so in figure 15. And obviously look at the sketch map below, you literally have hard and soft rocks there. The softer rock, I'll give the example of sandstone because that's in St Austell Bay. It erodes faster than the hard rock like slate, so the bay is formed as this area is eroded much faster. It's about 5 times the rate difference. Now the headlands stick out further and wrap around the headlands, called wave refraction, which protects the bay. Now the idea here is what we've done is we've started at the beginning of headlands and bays by showing that it only happens on an example where two different rock types face the sea, and then we've talked through using the so what rule how on earth headlands and bays are formed from start to finish with no gaps at all. Excuse me, as I just opened the door for my cat. Amazing. If I knew how to pause the recording, I'd probably do it at that point. Now, this is the problem which I spoke about earlier regarding not using the whole figure, because yes, you've talked about headlands and bays, but that's only half of the answer. Headlands and bays count as one feature, so you need a second feature as well. And that's where reading the key comes in, because look, they've given you 2 additional features. They've given you wave cut platform and they've given you beach. Personally, I would explain wave cut platform because they're a lot easier, but you're over to you can probably guess will be to explain the formation of a beach. So our second paragraph, the wave cut platform, much longer because there's a lot more formation to start with. But again, we start at the beginning. Wave cut platforms only occur on a cliff that can support its own weight. The rest of this answer here, I'll give you the chance to read through. I'm not going to read it through all the way through with you, but it's each step all the way through telling me how the sea undercuts, you get a wave cut notch, all the way through until you get a mass movement event forming the wave cut platform formed at the bottom. So what I would advise you do if you're over to you on this question is absolutely read through my explanation of a wave cut platform. Anything you need to add to your own, or if it's one that you want to get down yourself, by all means do so. But probably more importantly than that is to look at the beach landform as your other option here, and to try and write your own peel, your own paragraph to explain the formation of a beach. Any question at all, pop down to H7, more than happy to talk about coasts with you. It's one of my favoured subjects in geography.